Hello class, so let's try to look into number 11 together. So here we have, if you have to substitute 2x plus 1 for u, then what will happen? Yes, we have to look at the u by taking the derivative will be equal to 2 dx. So therefore, dx will be equal to du over 2. By putting all these things together, we will end up getting integral square root of u, because 2x plus 1 is equal to u. In place of dx, we're going to have du over 2. So we have du and then 1 over 2. Now how about the boundaries? When x is equal to 0, you will realize that u will be equal to 1. When x equals 2, by plugging in here, u will be equal to 5. So 1 through 5 in this manner. So our answer seems to be choice C. Alright, the rate of change of volume V. Here we're talking about the rate of change is V prime. It's directly proportional, so we have to constant of proportionality, which is K, to the square root of the volume. So that's basically what we're looking at. And out of these, choice E represents that. Alright, let us continue here. Number 13. In this case, which value of x is f continuous but not differentiable? Continuous and not differentiable, it can be something like corner or cusp. And you see that cusp right over here. It's continuous, it seems, but not differentiable. So here we have choice A would be our answer. Now let's take the derivative. In this case, we can take the derivative by the product rule. So we have 2x, which is derivative of the first one, times the second one, sine of 2x, plus x squared. Keeping x squared as it is, we are taking the derivative of sine of 2x. So sine of 2x, oops. Derivative of sine becomes cosine, right? So we have cosine of 2x. By the chain rule, we gotta multiply by 2 once again. So here we have 2x seems to be common, so if you have to factor out 2x, then we will have sine of 2x plus x cosine of 2x. So therefore our answer will be choice E. Alright, let us look at number 15 together. So given in this way, which of the following interval is decreasing? Now, the fact that function is increasing or decreasing, we have to look at this portion. When is first derivative is equal to 0, or second case is when is first derivative doesn't exist. To make that equal to 0, we can simply say x squared minus 2 over x has to be equal to 0. Then we get to realize x squared must be equal to 2 over x. By cross multiplying, we get to realize x cubed is equal to 2, where x is equal to cube root of 2. That's basically how we can find the one boundary. Do not exist, yes. X squared minus 2 over x equals 0. You see, when the denominator is equal to 0, then the whole first derivative wouldn't exist. So therefore, what we can do is, when x equals 0, is the another value. So here we have trying to find the interval where f is decreasing. Then we are looking at number line. And then here we have 0. Here we have cube root of 2. Now, let's try to check up on each values. If I had to plug in the negative number, this portion is always positive, but negative 2 over x will become now positive. How about the values between 0 and radical 2? I mean, a cube root of 2. One value which we can plug in will be 1. Once you plug in 1 here, x squared, we will realize that that becomes x. And then we have minus 2 over 1, when you plug in 1 over there, we'll end up getting negative here, and this will be in fact positive. So the interval which we are looking for is from 0 through cube root of 2, which is choice D. Number 16. Now, here, if the line tangent to the graph of the function f at this particular point passes through here, then what is f prime of 1? We have to figure this one out by finding the slope over here, because slope here has been determined by the f prime of 1. So when you look into this one, what do you realize? 7 minus negative 2 over 1 minus negative 2. So then here we have 9 over 3, which is equal to 3. So 3 becomes our answer. Number 17. We know that the graph is concave down when this portion e to the x will always be positive, so it wouldn't affect at all. Then to figure out the concavity, what we like to do is taking the second derivative. So first derivative becomes 2 times e to the, what does it say? E to the x, okay. Plus e to the x times 2x. That's basically what we end up getting. Now the double derivative becomes, here is simply 2 times e to the x, plus here we're going to have 2 times e to the x, plus taking the derivative of this one, we're going to have e to the x plus 2x. So when you factor out e to the x, we'll end up getting 4 plus 2x. So in this case, for what value will this be concave down? Obviously, x being at negative 2, we can figure out the concavities regarding the values around it. If for example, if the value is equal to 0, then we will realize that this portion will be positive. So this is positive concavity. If you have to put the value such as negative 10, then you will realize that this portion will be negative, which this is still always positive. So that's basically what we're looking at. X has to be less than negative 2. Alright, so we'll finish up the second part, and we'll move on to the third part very, very soon.